continue our chapter 8. This is called partial fraction decomposition. This is a new material. I don't think they cover this in intermediate algebra. So let's look at the example here. In intermediate algebra, if you have a partial fraction like this, you would find the LCM and multiply the numerator and denominator to get LCM. Combine like term and then simplify it. And your answer for this example should be 2 over 9x squared plus 1. Now for this section, they're going to give you this rational expression and ask you to find the partial fraction decomposition. So basically you go the other way. Alright, so we're gonna use different technique and there are different cases. You will need to understand this, and now you will see this again in calculus 2. So let's look at the first one. Find partial fraction decomposition. So I have 8x minus 19 over x plus 2 times x minus 5. This is for in this first case. You have a rational expression and the denominator, look at the denominator, is a product. Product means multiplication. We have multiplication of distinct. Distinct means they're not the same. So this is distinct. Non-repeat, they're not repeat. Linear. It's linear. Then you're going to put in this form. So let me write this. I'm going to have 8x minus 19 over x plus 2 times x minus 5. So it's going to equal to this. So it's going to equal to a. I'm just going to call it a. So the first term is distinct. So you're going to have a over x plus 2. Plus, instead of a sub 2, I'm going to call it b over x minus 5. So I follow this case here, the first case. Now, the goal of this, we're going to have to solve and get your a and your b. Then you're going to have partial fraction decomposition. So what I'm going to do, I'm going to multiply both sides by x plus 2 x minus 5. So I'm going to multiply x both sides by x plus 2 x minus 5 to get rid of the fraction. Alright, so if I do that, on the left hand side I would have 8x minus 19 equal a times x minus 5 plus b times x plus 2. So I get rid of denominator. Alright, so we have to figure out what is a and what is b. The first technique, I'm gonna equate the coefficient. So what I'm gonna do, I'm gonna have 8x minus 19 equal to ax minus 5a plus bx plus 2b. Alright, now you can see on the left hand side you have two terms. One is x, the other one is just constant. Alright, so I'm going to rearrange on my right hand side to have coefficient and constant x, or coefficient and variable x, and then constant. So what I'm going to do, I'm going to make it two terms, just like the left hand side. So I'm going to combine the ax plus bx, and then I'm going to have minus 5a plus 2b. My goal is I want to have two terms like this. Alright, so I'm going to have 8x minus 19 is equal to a plus b x minus 5a plus 2b. So think of it as two terms. This it should equal to this. Alright? And the second term is equal to that. Alright? So I'm gonna set it a plus b should equal to 8 because this term equal to that. They are a coefficient of x. right? And the second one, I'm gonna have negative 19 is equal to this whole thing here, my second term, minus 5a plus 2b. From here, I have two variables, a and b, and two equations. You can use addition method, you can use substitution method, however method you prefer, and solve for a and b. I'm going to use substitution. So I'm going to do my a would equal to 8 minus b. And then I'm going to substitute in here. So I'm going to have negative 19 equal negative 5. Instead of a, it's going to be 8 minus b plus 2b. Now I only have one variable, which is b. Then I can solve for b. Negative 19, 40 plus 5b plus 2b so far. So negative 19 is equal to negative 40 plus 7b. Alright, so move things around. What is that? 7b is equal to 21. So my b is equal to 3. Now I get my b, I need my a. I just have to go back to one of these. So I can go back here. So a, I'm using this one here. Let's do it here. So a would equal to 8 minus b is 3. So my a would be 5. Alright, so I have my partial fraction. It's going to be a, which is 5, over x plus 2 plus b. What's my a? Oh, yeah, it's 5. b is 3 over x minus 5. So that is my partial fraction. Alright, let's look at more example. Hi, let's look at more example. Look at this example. I have x minus 1 divided by x plus 1 quantity square. So we cannot use the first case. The first case, you have distinct product of distinct linear. This is repeat. I have repeat linear. So I have x plus 1 quantity square. So I have to use this formula. So I'm going to rewrite this. So if I rewrite this, I'm going to have x minus 1 over x plus 1 square equal to a over x plus 1 plus b over x plus 1 square. I will stop here because I have square here. If you have the third, you will have c over x plus 1 to the third. Right? Next step I'm gonna do is I'm gonna get rid of the denominator. So I'm gonna multiply by LCM, which is x plus 1 square. So I would have x minus 1 equal to a times x plus 1 plus b. Alright, because I multiply everything by LCM, which is x plus 1 square. So this one I'm going to put in a box for now. Alright. So I will try to get rid of one variable at a time. It's different technique. I don't equate the coefficient like the first example. This is another technique that you can use. So if I want to get rid of a, I will let my x equal to negative 1. If x equal to negative 1, my a will disappear. So that's what I'm going to do. So I'm going to let my x equal to negative 1. So I have negative 1 and negative 1, which is negative 2. And then if x is negative 1, a disappear. So I just have my b equal to negative 2. Right? I have two variables. I got my b. Now I need to get my a. So let's say I'm gonna let x equal to 0 and use b equal to negative 2 because I have my b already. if x equal to 0, then I'm going to have -1 because I substitute 0 here. -1 is equal to a, x equal to 0, so it's 1, b is -2. Alright, so this implies my a would be 1. Yes, my a would be 1. I got my a and my b, so my partial fraction decomposition will be 1 over x plus 1 minus 2 over x plus 1 quantity square. If you want to check, you can subtract these two fractions. You should get the original back. Alright, so let's look at the next example. The next example, I have 6x over x to the cube minus 8. This is not linear. This is not distinct linear. It's also not repeat linear. So you cannot use the first and the second case. But let's rewrite this. I'm going to rewrite this. This is difference of square. So I have 6x over x minus 2 x squared plus 2x plus 4. That's the difference of cube. The first denominator is linear. The second denominator here, the product of it is a quadratic. So I'm going to use the case 1 and the third case. You have non-repeat. It's non-repeat. Irreducible. This is not reducible. So you're going to use this formula. So I'm going to rewrite this. I'm going to have 6x over x minus 2 x squared plus 2x plus 4 equal. So the first case is this one. It's going to be a over x minus 2 plus the third case, which is this one. I'm going to have bx plus c over the non-repeat irreducible, which is x squared plus 2x plus 4. Alright, the first case and third case. Now what I'm going to do is I'm going to get rid of denominator. So this is my LCM. I'm going to multiply everything by LCM, which is this one. Let's say LCM is x minus 2 x squared plus 2x plus 4. I'm going to multiply everything by LCM to get rid of denominator. So I would have 6x on the left hand side is equal on the right hand side. If I multiply by this will cancel out. I'll be left with a times x squared plus 2x plus 4. And if I multiply this to this, I would have 4x plus c times x minus 2. That's correct. So let's box this. Alright. Now I have 1x here, I have x squared. I can only equate the coefficient. So I'm going to use the similar method that I did in this example. I'm going to figure it out. I want to get rid of one variable at a time. I see x minus 2 here. If I let x equal to 2, this whole thing will disappear. So I'm going to let x equal to 2 and substitute in here. Then x equal to 2, I have 6 times 2 is 12. Is equal to a, I don't know what it is. 2 squared is 4 plus 4 plus 4. The second term, x equal to 2, is just 0. So I have 12 is equal to 12a. Then my a is equal to 1. Alright, my a is equal to 1. I have my a, now I have to figure out b and c. Now I'm gonna let x equal to 0, and I'm going to use a equal to 1, all right? And I'm going to substitute in the original one in the box here. If x is 0, 0 times 6 is 0. So I have 0, my a is 1, right here, 0, 0, then I have 4. My x is 0, so I'm going to have c times -2. All right. Let's see, what do I have here? 0 equal to 4 minus 2c. This implies 2c equal to 4 or c equal to 2. Right? So I get my a, I got my c, I need my b, then I'm done. So I'm gonna let my x equal to 1 now and use a and c here. Plug it in here again. Always plug it in here, all right? The one that you multiply everything by LCM here. So let's see, my x is 1. 1 times 6 is 6. My a is 1. My x is 1. So I have 1 plus 2 plus 4 plus my b, I don't have my b. My x is 1, so b, plus my c is 2. My x is 1. 1 minus 2 is -1. All right. Now we just need to solve this. So I'm going to have what? 6, 3, 7, plus, I can distribute this in, so it's going to be -b minus 2. Right? So I'm going to have what? Let's go here. I'm going to have -1, and with 7, -1 equal to -b, -2. So b will equal to -1. So I have my a, my b, my c. You just plug it in this equation right here. Since I don't have room, I'm just gonna read it. So you're gonna have 1 because your a is 1 over x minus 2 plus negative x plus 2 over x squared plus 2x plus 4. All right. Now the third one, oh no, I'm sorry, the fourth one is a bit complicated. It's repeat, irreducible, quadratic. So it's quadratic, it's repeat, this is repeat, and you can reduce it. So this is the formula. You will see again this formula in Cal 2. For pre-Cal, I will not test you case 4. All right, so see you again next section.